Hi guys, this video today is going to cover the example number 2 from the linear programming lesson. The first video was from last night, and then this video tonight is going to cover example 2. Let's just dive in and start reading the problem. Yum's Bakery bakes 2 breads, cinnamon raisin and banana nut. One batch of cinnamon raisin uses 5 pounds of oats and 3 pounds of flour. One batch of banana nut uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. Okay, our first step here is to define the variables. And quite honestly, there is a lot going on here, and sometimes it's hard to decide what should the variables be. And so as you think about this, you have several options. You could have cinnamon raisin and banana nut be the variables, or you could have oats and flour be the variables. It's really hard to tell. And so sometimes I actually wait on the variables until the second part, and I do the constraints first. And so our constraints, remember, are our limitations. And so if we look at what the limitations are, well, we have one limitation of oats and another limitation of flour. So my constraints is I only have so many oats and so much flour available. So my constraints in this case are oats and flour. And if so oats and flour are the constraints, then the variables must be the other ones. So oats and flour are the constraints, so the variables must be the cinnamon raisin and banana nut. And so sometimes if we decide our constraints first, then we can decide our variables based on what's not the constraints. Another way to do it, and this problem I hadn't laid out the whole problem yet, so if we go down to the bottom of the page, the rest of the problem says Yum's Bakery wants to maximize its profits from bread sales. One batch of cinnamon raisin yields a profit of $40. One batch of banana nut yields $30. How many batches of each type of bread should they make to maximize their profit? And so here is another clue into what our variables are going to be. When it asks you how many batches of each type, that tells you those are the variables. And so that's just another way to remember where to find your variables, is frequently when they have a long question like this, the very end of the question will ask you something specific, and whatever they're asking there, those are your variables. Okay, so we know the variables, we know the constraints, and now that we know the constraints, like in concept what they are, then we can start looking at the problem and coming up with some specifics. So as far as oats goes, the problem says that they have 180 pounds of oats. So that's one of the constraints, is how many oats they have. So 180 pounds is the most that they can use. So that has to be greater than or equal to. Okay, now we have to go and look at the problem. It says 5 pounds of oats. So it's 5 pounds of oats for cinnamon raisin, and it's 2 pounds of oats for banana nut. Okay, so you had to kind of pull through from various places in the reading to pull that together. But the 5 was for the oats and the 2 was for the oats. And then that has to add up to less than or equal to 180 pounds. The other constraint is the flour, so we're going to do something similar, and we're going to read through and find out where it says flour. So it says 3 pounds of flour for cinnamon raisin, also 3 pounds of flour for banana nut. And the constraint is that it has to be less than or equal to 135 pounds altogether. So these are our constraints. These are what we go ahead and graph. So we need to figure out our graph and how to lay it out and what kind of increments to use. And so sometimes before you do that, you might want to come up with your table of values so you know how high to go. These are both in standard form, And you could use the table of values with the zeros in it. That is the cover-up method, or finding the intercepts. So I can do that method, and if I do that, if I plug in a 0 for x, then I take 180 divided by 2, that's 90. If I cover up the y, I get 180 divided by 5, and that's 36. If I cover up the x on this one, then I get 135 divided by 3, and 135 divided by 3 is 45. And if I cover up the other one, it's also 45. So as far as my increments go, I have to get up to a 90. And this graph counts by the dark lines are 10, or there's 10 of the dark lines. So in other words, we could just count by 10s on the dark lines. Okay, how to set up our graph? Well, we defined our variables here. Those are the same variables we need to stick to put over here. Okay, so if x is the number of batches of cinnamon raisin, that goes on the x-axis. Y-axis is the number of batches of banana nut. It's getting a little crowded in here, but I'm just going to count, like I said, where each dark line is 10. So that's 10, that's 20, that's 30, that's 40, 50, 60, 70, 80, 90, and 100. And I'm going to do that same thing on the y-axis. Now, I only marked every 20, which you can do. If you would rather mark every 10, that's okay too. I know that with my marker that I don't have enough space to do that. Okay, now we need to graph these. This first equation has a y at 90 and an x at 36. So I'm going to plot 90 and 36, and I'm going to connect them with a straight edge. And it is less than, so I'm going to shade less than. In other words, when I say less than, as you see the y is over here, so y is less than, but all of this has to be less than 180, so this is going to shade this way. And then for the other line, I'm going to plot a 45 and a 45. So I have a 45 here and a 45 here, and I'm going to connect those with a straight edge. And once again, it has to be less than 135, so it must be in this area here. And so my area that I'm talking about is this quadrilateral in here. I'm going to do some erasing so you can see specifically. Okay, so this is the shaded area that I'm talking about. It's this quadrilateral here. I need to find the vertices. When we talk about finding the vertices, we only need the vertices of the shaded area. And only, in other words, only if the corner is touching the shading, that's what we need. So if you look at your graph, you do not care about that point up there because it's not touching the shaded area. This point would work for the oats, but it wouldn't work for the flour. Similarly over here, this would work for the flour, but it wouldn't work for the oats. So we don't need those. The only ones that we need are the ones that have the shading of all of the areas, because that's the one that works for everything. So we're going to take a minute and find the vertices. As usual, some of them are easy to find, some of them are not. So take a minute here to find at least 3 of these vertices. Okay, actually all 4 of them you might have been able to find by looking at your graph, so I'll talk about that. But before I talk about that, there's a constraint, actually 2 constraints that we left off. We cannot have negative amounts of bread. So we can't have a negative amount of cinnamon raisin, we can't have a negative amount of banana nut, so we do need to have those as equations. I guess we could have 0, but we can't have it less than 0. And so a line, actually 2 lines that we didn't draw, we should have a line here on this axis and a line on the x-axis, and it's greater than, so it's still this same shaded area that we've been talking about, but I should include those. I had left those off before. So make sure you include those. Okay, the three that we could easily see, we could all see the 0, 0. We could all see the 0.45. We could all see the 36.0. The 30.15 is the one that might have been harder to see, but if you had a decent line, it should have been on your graph. But if it wasn't and you needed to check it, just remember you have to plug it into both equations and make sure it works in both equations. So you would take 5 times 30, that's 150, plus 2 times 15, that's 30. So 150 plus 30 is 180. That does work. I'm going to plug it into my bottom one. 3 times 30 is 90. 3 times 15 is 45. 90 plus 45 is 135, so it does work in that one as well. So that is the correct answer, or those are the 4 vertices. Here's why we find the vertices. The vertices actually tell us where is the maximum value or where is the minimum value. So all of this shaded area in the middle are potential things. Like we could make this many, that's hard to see, but like 20, 20, that's one I can tell is in there. We could make 20 of each, and we would stay within the constraints. Or obviously we can make 10 of each, and it would stay within the constraints. Any of these points in here would stay within the constraints. But the question is, well, where is it to maximize? I want to maximize it. So in order to maximize it, I'm going to have to use the corners, the vertices. That's why the vertices are important. And so the last step here is to read through here and come up with our maximizing or minimizing equation. And so if we read through here, they say that Yum's Bakery wants to maximize its profits from bread sales. One batch of cinnamon raisin yields a profit of $40. One batch of banana nut yields $30. So I'm going to set up an equation. I'm going to call it M for maximum, but you could call it P for profit. But this equation is going to deal with the profits. One batch of cinnamon raisin, and that was our X, yields a $40 profit. One batch of banana nut yields a $30 profit. And that was our Y. So now I have this equation. Now that I have this equation, I need to plug each of these points into this equation to see which one comes out with the maximum value. So I'm going to take some time to do that. Okay, so to do this, I'm going to list out all my 4 vertices. So I take each vertex and I put it here, and I'm going to plug each one into this equation. So I'm going to plug in 0, 0, I'm going to plug in 0.45, 36.0, and 30.15. And now I need to go to my calculator and figure out what each of these equals. Well, the first one is easy. That's going to give me $0, which if you're trying to maximize profits, that's not going to win. That would win the minimum, and sometimes it asks you to minimize. So that would be the minimum. But in this case, it's not the maximum. All right, if I plug in 0.45, I'm going to work that out. And when I plug in 45 times 30, I get 1,350. Now I need to take 40 times 36, so I'm going to do that on my calculator. And I get 1,440. And lastly, I need to plug this one in and see what I get there. And so 40 times 30 is 1,200, and 30 times 15 is 450. And so I add those together and I get a total of 1,650. And so what I'm supposed to do now is I'm supposed to look at which one is bringing in the most profits. And so obviously this last one is going to bring in the most profit. Let me give a couple of warnings and kind of a summary. The summary would be Well, it's a long summary. There's a lot to go through, right? You have to figure out your constraints, figure out your vertices, graph them, find it, all that. It's a lot of work. And I'll talk about something we can write down in our summary for just a minute. But a warning is that we do a lot of these problems, and people sometimes think that it has to be the one that's not on the zero. In other words, it makes sense, doesn't it, that if this has a zero in it and this has a zero in it, but this doesn't have any zeros in it, isn't this one going to be the biggest one? Well, sometimes it is, but sometimes it isn't. So you just have to be careful. You can't just say, oh, it's always this or always that, because it's not. You really have to check it to do it. So you really do have to do all this of plugging them in. It doesn't take very long. You just get out your calculator and you do it, and it doesn't take too long. Now, as far as what to write in the summary, as I said in the beginning, I think one of the hardest things is finding the variables. And so as far as a summary goes, there is lots of stuff you can write in your summary. But here's what I mentioned in this video. I mentioned that to figure out which ones are the variables, there's two options. You could list the constraints first, because the constraints are a little bit more obvious. People are able to get their brain wrapped around what, how much, you only have this much time, you only have this much flour, whatever. List those first, and then figure out that the variables are the other thing that they're talking about. That's one method. The other method would be to look at what the final question is asking about, and that is the variables. So in this example, the final question was, how many batches of each type of bread should they bake? And so that's the final question. So our variables are batches of bread. You can write whatever you need to in the summary, but I felt like that was an important thing that people struggle with. All right, we will continue to work with these linear programming problems in the next couple of days, and your job as a project is going to be to create your own linear programming problem and solve it.